Good morning, students. Do liquids have weight? Yes, liquids will have weight. Can they exert pressure? Liquids and gases also have weight. They can exert pressure. Do they have a definite shape? No, but they take the shape of the container into which they are taken. Where do the liquids exert pressure? Let us study a few simple activities to know on which surface the liquids will exert pressure. Consider a transparent glass tube opened at both ends. Tie a good quality rubber balloon by stretching it over one end of the tube. Now, the tube should be kept in a vertical position by holding it in the middle. Pour some water in it. What will you observe? The rubber balloon bulges. Let us pour some more water. We can see the balloon becomes larger. It bulges more. From this activity, we understand liquids exert pressure on the base of the container into which they are taken. Also, the pressure exerted depends on the height of the liquid column. If the height of the liquid column is more, the pressure exerted by the liquid will be more. And if the height is less, the pressure will be less. Liquids exert a pressure downwards on the bottom of the container. Let us study one more activity. Take a discarded water bottle and also a glass tube. Now, the glass tube has to be inserted into the bottle at its bottom as shown in the diagram. For this, you need to heat one end of the glass tube slightly and then quickly insert it into the bottle. We should check that the water should not leak from the joint. If water is leaking, we should take a little molten wax and seal it. But we have to ensure that the water does not leak. The open end of the glass tube is now covered by using a rubber balloon as we did in the first activity. The bottle has to be filled up to half with water. We will observe that the balloon bulges out. Let us pour little more water and observe. What do you see? The balloon will bulge more. Remember, in this activity, we have fixed the rubber sheet or the balloon on the sides of the container and not at the bottom. So from this activity, we can say that liquids exert pressure on the walls of the container. Pressure exerted by the liquid sideways on the walls of the container is known as lateral pressure. Also, the balloon bulges more on adding water because when water column increases, the pressure increases. Lateral pressure increases with depth. Not only downward pressure and lateral pressure, liquids also exert upward pressure. Take a ball in your hand and try to push it into a bucket of water. You will experience the ball is being pushed up by some force. This is due to the upward pressure of the liquid acting on the ball. Consider that we need to draw a bucket of water from a well. When we put the bucket into the well and it is inside water, the bucket is filled with water. Yes, but we will not feel the weight of the bucket when it is inside water. But the same bucket, when it is drawn out of the water, we will feel its weight. This is because the water exerts upward pressure on the bucket when it is inside the water, and we will feel the bucket to be lighter. So we have seen that liquids exert downward pressure on the bottom of the container, the lateral pressure on the side walls of the container, and upward pressure on the object which is inside the water. Now, consider an empty plastic bottle. Make 4 holes all around near the bottom of the bottle at the same height. Fill the bottle with water and observe. Jets of water come out of the holes made in the bottle, and they will fall at the same distance from the bottle. By this activity, we can conclude that lateral pressure of the liquid is equal at the same depth. Lateral pressure is equal at the same depth. In this image, you can find a beaker with 3 holes made in it at different heights, and the beaker is filled with water. From which hole in the beaker is water coming out with more force? The hole at the bottom. Water coming out from the hole at the bottom is falling at a greater distance, showing that pressure is more at the greatest depth. The pressure of water is least on the topmost hole of the beaker as the depth is less. We can say from this that pressure of a liquid increases with depth. So the pressure of water is same at the same depth, and it increases with depth. Now, let us see whether the liquid pressure will be same for all the liquids or not. Different liquids exert different pressures. Pressure exerted by a liquid depends on its weight. The liquid which has less weight exerts less pressure, and the liquid with more weight exerts more pressure. Oil being lighter than water exerts less pressure than water. So, liquids exert different pressures. The lighter liquids will exert less pressure, and the heavier liquids will exert more pressure. In this image, you can see water coming out of the leaking joints or holes in pipes which supply water. It is due to the lateral pressure exerted by water on the walls of the pipes. You can see the wall of a dam. It is made thicker at the bottom because water pressure increases with depth. A thicker wall can withstand a greater pressure exerted by the water at the greater depth. That's the reason why dams have thicker walls at the bottom. Liquid pressure can be measured by using a simple device called manometer. The apparatus consists of a transparent U-tube fixed vertically to a board which has a scale marked on it. the U-tube has to be half filled with water. The level of water in both the arms of the U-tube will be same. Let us name the arms of U-tube as A and B. Attach a rubber tube to arm A. Now, at the other end of the rubber tube, fix a funnel which has a thin membrane stretched across its mouth. You have to stretch a thin rubber membrane stretched across its mouth. Now, our manometer is ready. Now we can use it for measuring the liquid pressure. A large glass beaker filled with water is taken. Try to put the funnel of the manometer slowly into water. The water level in arm A of the U-tube goes down and water level in arm B goes up. When the funnel is inserted into water, the water in the beaker exerts upward pressure on the rubber membrane, which is stretched over the funnel. This pressure pushes the water in arm A down and water in arm B up. The difference in the levels of water in the two arms can be observed on the scale which is fixed on the board, and this gives us the pressure of the liquid. If the funnel is taken deeper, the difference in the liquid levels in arms A and B will increase, showing that pressure increases with depth. So we have seen how to measure liquid pressure with a manometer. In the next module, we will discuss about atmospheric pressure and its applications.